Hi, thanks for joining me this morning in my shop. I'm going to be going the next step with the alignment on here since the end of the last video and the start of this one right now. I did go back and review quite a number of the calibration processes that I had done where I was concerned I'd made errors. And as it turns out, not really, but I did get a little bit of a better result in doing that particular test where you have the extra 2000 ohm resistor installed and you look for a little bit of wiggle up here. I did manage to see a tiny amount of wiggle, which reassures me that the test process worked. And so anyway, I went back, checked those things. Everything's okay. I'm ready to continue forward from where I left off yesterday. So that's what we're looking at up on the screen there. So step K is what I completed, the last thing I completed. And just to talk about that, when I began to adjust P3, I found it was at one extreme. It was at the, I believe, the counterclockwise extreme. And as I brought it, as I turned it through its range, the meter got closer and closer to where I wanted it to go. And then the control hit a stop. It reached the other end, actually. It's very close to where it needs to be. And that's how I've left it. So that test, you flip the switch here, you shouldn't see the pointer move. It does move a little tiny bit. But the interesting thing is, it looks like that control was left in its starting position, so to speak, as if this machine never got calibrated. So, you know, an interesting question, I'm just looking at it now, is how much use did this thing actually get? And so what I'm looking around some of the knobs that would get worked a lot. I'm looking for any evidence of wear, but you know, there isn't the slightest bit. So it's possible this thing basically never got used. Who knows? I have no idea who had it, or you know, was it in a repair shop for a while? I have no idea. So here I am. I'm right here, and everything is set to go, I think. Tube in place. The tube must be in place for this test because up here it says, you know, look for shorts. The only way you can look for shorts is to have the tube in place. So I'm going to put the tube in place and we're going to do this part here. Okay, we'll put the tube number 1 in. Try and use the same tube. Double check. Let's double check here. 50. Oh man, I made a mistake already. 50 L6, let's see. 50 BGAG. BGAGG, yep. Unimportant. This first test, 06431. 06431. 05200. 05200. Okay, check that. Bias is going to be 1.4. Shorts on 2 and 7. Okay, let's flip the switch on here, and we'll put the power on with the dim lights here. You can see the line voltage indication coming up. Everything's fine. We'll put on full power here. Tube is lighting properly. Line voltage is right in line. Put on bias. Turn the bias up. Whoa, she's a wild one. 1.4. Oh, that's right. I had a hard time with this, didn't I? So, ay. See it whack against the limit there? You know what we're going to do with this right now? We're going to do another thing. I'm going to rotate this and see if this doesn't change the limit spot there. Okay, so I'm gonna push the meter up against the limit and then turn this. See if it goes further. On the limit now. No. No. Okay, now I gotta put this back on 0 properly. How would I ever do that? Best thing is turn the machine right off, I think. Seem to drop pretty quick to where the 0 is. Well, I was kind of hoping that might solve it. There we are. Fear not. Bias check again. We're on the money. Maybe I should clean this bias control at this point. Why don't we do that? Let's do that. Power off. Power off. Power off, everybody. Okay, I'm gonna flip it up. We're gonna try to clean this control here and see if we can get it to. Gotta do it sooner or later. Might as well do it now. Great big one there. Now I've got to look for a hole or some way to spray cleaner inside of it. So talking about cleaner, hey, look at that. This is my this was my tool for cleaning the coils in my fridge yesterday. I had to reach in, so I manufactured this fantastic tool. I'll use it on here too. Yeah, I cleaned the coils on my fridge. Boy, oh boy, I should have done that a long time ago. Well, there's a hole right there. There's a hole right in the back there. Yeah, you know, so I could spray crap in there. WD-40 is what I would tend to want to spray into there. And I'm looking for any gaps. Usually there's gaps where the terminals go in. Hold still. Looks pretty tight in there. Looks almost like you could pop that cap right off the back, doesn't it? Like put a screwdriver on it, just pop that cap right off. Is that possible? Let's look closer at this. You know what? This isn't a hole. This is a tang. That's a tang sticking out there. You bend that tang and the top will come off. You look right inside. Yikes. Wow. Should I do that? What's it say on here? $3,000. Well, first of all, I don't know that even spraying cleaner into it is going to fix it. I don't know that the problem in it is repairable. It's dirt. It could be a worn spot or a burn spot. I don't know that popping this cap off won't let the guts come flying out. I don't know it's spring loaded, everything fly out. I don't know. I don't know that. It sure looks like it's been made to take apart though, isn't it? I mean, it's almost nothing holding it together there. If that tab is it. Is that another hole? Right in there? No. It's a piece of dirt. So now if we leave it intact, which is the best thing to do, can I just spray it in that hole and hope it gets somewhere? It's not unreasonable. If you blast WD-40 into something like that, or some kind of spray, if you blast it in there, it can get around. What harm can it do? What harm can it do? This is one of the capacitors I put in. I'm just checking it. Doesn't look very well soldered over here. Just trying to make a decision here. Well, I don't think that I don't think WD-40 is going to harm anything. I've never had it harm anything. I know there's some concerns about the solvent in it, and there's some concerns about it weakening like non-metallic materials, stuff like that. But what are you going to do? Let us blast it. Give it a blast in here. It's going to be a lot of kickback, so I want this stuff going everywhere, but I know it's going to kick back. I'm gonna have to get gravity working for me too. Get gravity on my side. Oh, I got the tube plugged in still. There we go. I'm going to want to get at the control here too. Yeah. Feels like it's wire wound, you know. As I turn it, it's the size of a wire wound one. It's doing the duty, I think, of a wire wound thing too. You know, it's dissipating a lot of heat. Wow, I spray that stuff into a wire wound one. How's that going to help? See, here's one here that's wire wound. You can see the contact and everything. This is the rheostat for adjusting, for compensating for line voltage. Ah, man, decisions. Peanut says go for it. I heard him. Say don't? What are you saying? Yeah, she's soaked in there pretty good, boy. I put a lot. I don't know how much of that actually went in. Probably not a lot went in. My guess is this made no difference. There's something funny in there. Huh. Feels like there's a second thing sliding around, and the thing I'm turning is bumping into the second thing and moving it. You move it here. Then you come back here, then it'll bump into it over here. You move it, and then you turn back, it bumps into it here. I don't know what that could be. I think that's probably mostly my imagination. I don't know what that could be. Okay, try it out again. We're all set for this tube still. Tube number 1. Line off, test. Bias is way up. Let's turn it down. Let's click on this. There. So we're just trying to get to M there. You take the test, note the amount, and then we change the scale here. Oh my gosh, Peanut. What is it, buddy? There he is, making his daily visit. Peanut. So, are you tired of winter? You ready for spring? There's Shadow at the door too. Both cats are here now. Come on, Shadow. I'm being ganged up on. Come on in. Gosh. What are you doing? You like that shelf, eh? Ooh, that's a good one. you happy now? I don't know, he seems to have fallen in love with that show. Let's get back to work. Back to work. Now, it's no wonder I mess up all the time with the constant interference from my cats. Ready for power on? Yes. And the power, how come this light didn't? Yes, it is on. Okay, full power. So we're in line test mode. Seeing the line levels coming up right on the money. Bias adjustment next. 1.4. Let's see if this is better. It's no better at all. It's absolutely the same. It's worse. You know what? This has become worse. Why is it doing that? Why is it jumping all the way from here way up there, and then it becomes adjustable? Well, until it hits the stop. Ah, phooey. See that? That's the leave well enough alone rule. Oh, I gotta get, it's supposed to be here. Oh my gosh. Yeah, tube current's probably flying up and down while I'm doing this. Well, it looks like we got to work on this bias control. We can't have a tube tester like this without a working bias control. So my guess is the contact is lifting right up. There's no contact until you get up. See, that doesn't even make sense, does it? Do you think you would adjust the control this amount to get a full screen reading there? Yeah, of course, the same thing on the other scale, of course. Let's see. If I set this to, let's say, 5. No, 5 is where it sticks. 5. And the other scale, 50 scale. You know what, on the 50 scale, I would tell you that's 12 volts. Huh. Like that. I would say that's 12 volts. For sure. And on the 10 scale, can't be 12 volts, can it? I would tell you that's 7. Maybe there's some calibration thing. Maybe I'm on the verge of calibrating this right now to correct that. That's way out. What am I going to do here? Decision time. Wow. I was going to say maybe I can replace this. What are the chances I have a replacement? Like, the chances are 0. Pretty well. How can we find more out about this thing without doing something to it? Power off. I think it's all about the bias control from here. I think that's where we're at now. I don't think it's worth doing anything else till I've settled down this bias control. Let's take a look on the schematic here. So the bias adjustment. Oh my God, where am I going to find it in here now? You know what? I probably can't identify it easily. In here. Oh my gosh. They didn't bother labeling what each of these controls do. Ah, yeah, I can look around this all day and never find it. Son of a gun. If I were a bias control, where would I be? Well, if I knew the resistance of the control, I might be able to spot it by resistance, because they've listed the resistances here. 10K pod here. Oh my gosh. Another way would be to figure out the grid wire. That's what the bias voltage is applied to. And then try to track the grid wire back. Yeah. Don't think that's happening either. grid voltage. It must be a well, I would think, no, I was going to say be a well-filtered voltage, but not necessarily, because there's a comment I read in the manuals. By the way, thank you to the viewer who sent me a complete set of manuals for this thing, which I've been studying. Thank you very much. That's going to save me. In fact, let's look at them and see if it doesn't save me right now. Okay, here we are. So you see these tabs opened up at the top of my browser here. These are all the different documents related to this guy. Now, a lot of this is the same information over and over, but not always. Nope, no schematic here. Go here. Schematic here. And why was I all excited about looking at the schematic? Parts list. I want to look at a parts list. Here we are. This is what I'm after. Check this out. So, okay. Now, is this going to show me the parts I need to spot? P2. Okay, so it's called P2. I got it. P2. We're looking for P2. Potentiometer number 2. P11. Hard enough, just P2. Oh my gosh. 6, P7, P8. These are P15. Well, let's see if they've been numbered. P2 should be right up near the front here somewhere. This is P4. 13, 12. How have they numbered these? P2, 3K, there it is, P2. Okay, so you can see P2 sitting right there on a little bit of schematic that's on the screen. 3K, P2. Okay. So I could desolder these connections and remove it and work with it in my hands. I'm not sure what the advantage of that is. Let's move this out of the way here. Well, I'm really tempted at flipping that up, popping the top off. Let's give that a try. See if I can get a little better camera shot of this here. Okay, there he is. Now, this could be the last thing. This could be the last thing that happens with this. These tabs, you know, you can only bend them so many times and they break off. So I want to bend this just enough. That's probably enough. Now can we get this cap off? Oh, comes right off. Comes right off. Man, I've taken so few of these apart because yeah, it's full of WD-40. Okay, I see how this operates. I've seen these before. Let's get a close look at it here. Excuse me. So, this is kind of surprising how this works. I don't think WD-40 is going to help out with it. Probably want to get most of that out of there now. So let me rotate the control and you can watch for yourself what it does. See if, remember I said I could feel, it felt like there was something more turning under there? No, this doesn't work the way I expected it. Quite interesting though. So to give you a little better of a 3D perspective here, let me hand hold the camera so it's wiggling around. That'll give you a little better 3D impression here of what's going on. So basically, so we've never seen anything quite like this. So we have this contact down here, obviously sliding on this surface, now covered in WD-40. Now this is a continuous piece of metal that rises up. It's fixed to the rotor here, to the handle. Rises up and eventually meets this part where it becomes another contact on this outside sliding area. Is this outside, is that the fine wire here? Ah, that's probably fine. Yes, hear it? I'm hoping you can hear that. Hey, there's a... The significance of the tab, I think it is just to hold this on. So the lower contact looks like it's perfect. You know, looking at the way it slides on there. It's this upper one. And let me get my focus on maximum here because I'm pretty sure I can see problems in that thing. I get as close a look as I can. Well, I know what I'm seeing. So the wires have bunched up around here. They haven't stayed in place. Or is that a pattern? I don't think so. The objective is to wind this wire so it's not in contact with itself anywhere. But you can see lots of places it's in self-contact where it's been pushed along the form. This also tells me that this control has been rotated a lot, or did all this happen since I got this guy? Up here at the far end, which end is which? It doesn't really make sense to even ask that question. So here the wires look to be in really good shape. So we need to get a little distance. So this is basically a mechanism that poorly engineered, didn't work. Didn't work in the end. Now, why is it the slider? You can see how they've made the slider. It's supposed to ski over those wires. Why would it not be skiing? Now, first of all, how much tension is on that guy? Because it looks like quite a bend in here. That's, you know what, that's a lot of force. There's no way we can look under it to see if there's something funny underneath here, but I think this is a single piece of metal. It's dished in a very, you know, it's like a ski. So the reason those wires would move is only because they weren't on the form tight enough, and they ended up moving. So you know, other than making the control a little bit stuttery, look at all the wire right at the end there. Why does it look a little different at the end? It looks like it's got some extra material under the wire there. I think that's the hot area. Like if you have it set like this, you're engaging a tiny amount of winding there, or wire. And you dissipate a lot of heat right there. And you move further, you're dissipating the heat over a larger and larger area. So I'm feeling this as I turn it and watch it. Can't feel any of those bumps at all. You would not even know they're there. So what was it I was feeling? The idea is that this thing is not making contact. It feels like it might be floating in here. Is there any play in this? Can I possibly feel it? No, I can't. I'm trying to see if that's riding up off the wires. You can't be cavalier with this thing. This is the end of the tube tester. This guy should get completely wrecked. You think I got a 3,000 ohm wire wound high wattage resistor like this? What in heaven's name would I ever do? I'm trying to figure out what's wrong with this thing. So far I can't really see. It's interesting how they made this. Or is it the other contact? It's kind of hard to believe, isn't it? Because that's nice nice bright shiny metal with WD-40 all over it. Well, first I got to convince myself I don't have an exact replacement. Even if I did have something I could put in here, it might have its own problems anyway. Let's test with an ohm meter a little bit here. Hold still there, camera. I like to use my commanding voice now and then on the camera. Okay. Really? Good. Okay, around the outside. My stomach's growling. I think I got a contact here like this. Oh, come on, baby. Really? 200 ohms. $100 ohms. I thought this was a 3,000 ohm thing. I'm on the wrong one. Testing the wrong one, Jim. Crying out loud. Looked down and went, hey, this isn't built the way I thought it was. Oh boy. So let's go on the outside terminals of this. And we should see 3,000 here. It says 800K. That's like a million. That's a million it's showing now. A million ohms. I thought I read this at 3,000 in the manual. Turn the control, see if that shouldn't change it, but stuff happens, you know. 900K. Okay, let's measure one end to the slider. So I'll put this black lead on the slider. The dual slider, double slider. See what we get now. 1,000 ohms at this setting. Okay, so you can kind of see it's a little hard to see into this wire here, but the slider is here. And the ends of the wire wound resistor here and here, right where these terminals are. So I should be increasing the resistance as I go this way. Looks pretty good on the control there. On the meter, rather. What am I saying? Oh, so they got to the top. It died right off there. 700K. This is supposed to be 3K. This is there's a K there. So this is way off. Way off from this end. Yeah, the K is staying there. That's not K. So now we're getting down into 157 ohms. Just come up a little bit. The K is gone. And this is where it jumps when I'm trying to set it. It's going to jump right there. That's the spot. That is the spot. Let's take a look with a close-up camera and see if we can see anything. See anything going on. So the contact is the tab there. Okay, let's see. So it's right in this area that we have the problem. So you can't see the meter now, I can see it. So right now it's saying 500K. Okay, I'm going to move it. I'm watching the meter. It's not changing at all. 530. Oh, now it's changing. Right in here. 400K, 300K, 250 ohms, 300 ohms, right here. A little further this way. 350 ohms. 400 ohms. Oh, switch to K right there. Go back a bit. Bit. It's holding on to the K. 400K. There, switched right there to ohms, 300 ohms. It's literally an extra 1,000 right in here somewhere. Okay, so what I'm going to do is I'm going to move it until it gets off the ohms, it gets onto the K. Kind of a hysteresis thing. There it goes. I jumped it a little bit. And that's okay, so it's showing 400K now. Slippery. A little bit of pressure. 331 ohms. Pressure off. 340, 350. Is it just simply lack of pressure? Well, how could that be lack of pressure? Because once you get beyond this point, okay, the K comes in. Now it's all K from here. 500K. If I push on it, I think this control is in big trouble. That's what I'm starting to conclude here. 500K. So what? What is going on back here? Right in here somewhere. So I'm watching the meter and seeing if I short some turns here, do things change dramatically? Let me put the wider part of the screwdriver in. This is a pretty hit and miss thing I'm doing now. So I'm just staring at the voltmeter or the ohm meter, expecting it to suddenly drop. Apparently this is not going to happen. So if we have a break in this wire here somewhere, okay, let me change my meter, my testing approach here. I got a better idea. It's always a better idea. Put a regular lead on here. I'll slide this over the wire in here. So I'll turn the control so it shows. Doesn't matter. I just move it out of the way. Okay. So first, the tab I'm contacting. This should show a short circuit. This positive wire is no longer hooked up. Let's get it out of there. It's not confusing. So this is the negative lead from the voltmeter now. Onto the center tab of the control. Okay, touching the center tab internally, and we get a 0. Okay, now, so that runs around this lower shiny track. If I touch the contact to the track, you should see 0. Beautiful. 0. Now, if I come over and touch the wires near the contact, touch the the resistive wires, you should see a little bit of resistance in here. Some amount, 70 ohms. And the other side, I should get about the same thing if I go the same distance. About 90 ohms. So now I'm going to remove this from the slider. I'm going to put it on the wire wound part, the end closest to the problem area. So I'll go on the not yet to the problem area. And we should see just the low resistance here. So that's like 1.5 ohms. I slide it a little bit further. We see, wow, that ever jump up to 50 ohms. You know, that's reasonable. I got to make it to 3,000 by the end. Go a little further. Ooh, 400K. Okay, let's go. Okay, let's go back a little bit here. There is something funny looking about the wires in here. I don't know what to make of it though. So I come right here. We're already into the K? No, we're in ohms. 275. And if I look at this funny area and I go beyond it, it's close to it but beyond it. I think that's beyond it. 327. Just a touch further. The K is on. Oh, the K is gone. Let's go a little further here. I'm well past the trouble area now. There it is again, half a K. Now, I mean, the only conclusion is the resistive wire has a break in it, and the break is a bit of a high resistance thing. You know what? It could actually be open. Could that be open? If it was open, and crossing it, and of course you're crossing. You got all these wire tops, right? And you have this wide contact thing sliding over it. And if there's a discontinuity there, while you're sliding over it, you're bridging it. And so you would continue to see, I think, probably fairly okay operation until you slide the thing past the break. And the moment you do, this resistance problem injects itself and the bias voltage goes right up. What to do about this? What to do about this? Clearly putting in another 3000 is the best thing to do. Okay, so what does it measure across its the whole element? Yeah, this is the kicker. 900 kilohertz, 900, a million ohms, and it's supposed to be 3000. So that's really screaming out that. I mean, everything is screaming out the same thing. There's a break in the wire. A break in the wire. Is it in any way possible to spot that break? Phew. You know what? I'm going to put a microscope on this thing. We're really going to look at it. Okay, there's a shot that kind of gives you an idea what I'm doing. I've got the microscope set up just to look right into there. And what do we see? Here's what we see. Now, what to make of this? So, I would expect the break to occur right on the top where the slider goes over. And I would expect to spot a dislocation of a wire at that point too. Now let me swing the control right into where the trouble spot is. Okay, so I think it's right in here. In fact, I can feel something in the control when I move it right in that area there. I see two wires bunched together there. It's hard to say, isn't it? It looks like it almost looks like this is a form the wires are sunk into to keep. But then how would they shift if that were the case? And how shiftable are they? Oh my gosh! I think I can stick something in there and try and move one of those. Pretty darn. This is my tiny little tool. Look at the thing. Oh my gosh. Looks like I'm using a tree trunk. Now, if I can quickly find a needle. No needles. Okay, I have a pin with a fairly sharp point on it. Let's see what we can do here. Again. Look at that. That's how fine those wires are. What am I going to do with this thing? I'm not going to do anything with that pointer. Oh my gosh. You know what? I got to see if I happen to have something like that. Here's what I've got in my junk box. Wire wound resistors. That's a pretty good guy right there. What are the chances it's 3000? Oh, that comes right off. Kind of a very similar arrangement. You know, this is a possible replacement if it's 3,000 ohms or close. Ah, look at this one. Look at this one. 8 ohms. So I don't think we'll be using this one. You can hear that. Hear it running over the wires. That's my only 2. Well, let's check. This has never been installed. Audio level. Feels really good. Quick, let's check it out. Bring the meter over here. Okay, cross your fingers, this thing says 3,000 or somewhere near to that. This is it. What? Open circuit. No. How can it be open circuit? Go there. Oh, this thing really can't make up its mind, can it? 15 ohms. This is as wonky as the other one. So I'm on the center post now. I guess I saw 7K there for a moment. Well. Now, how come I can't see it on the outside? You gotta be kidding me. So one of the challenges in these things is how do you make the connection to the special wire that's here? And normally these connections are made just by mechanical pressure. I think that's what that is. I think that's just a clip on this end. It just, oh, there's another element in there. Oh my gosh, let's look at this under the close-up camera. Some more. Right, we're just having a great time here. Having a great time. So I got quiet. You see, I looked at this end, you see, where the compression is over the wire, and then I look at the other end, and the wire is back from the connector. But then look, wait 1 second, there's another element in there, down under. Another wire wound element in there. What the heck is going on with this one? Pretty quiet now. Well, I would never have imagined there'd be 2 elements in there. It looks like the slider contacts. So this upper slider, wait a minute. So you can see the lower slider and the upper slider. And then there's the 2 copper bands there that appear to be riveted together here at the back here. They look like copper bands. The two sliders appear to be the same thing. They short it together. So as you're turning the control, you're adding two variable resistors. You're extending or increasing two variable resistors. What's happening at the end here of this outside one doesn't really matter. That would mean, like one of these outside terminal, I'm pretty sure that's connected there, but the other one, where's the other one going? The other one must be going in behind, connecting to this the inside wire. This is not going at all where I wanted it to. Now, why couldn't we read resistances here? Maybe we can't read across it because, in fact, this part, I don't know, it doesn't make sense to me, does it? We are reading across it. We're reading across it right now. 122 ohms. Does that change as I do this? Look at that. So this control is not... I was going to say is not compatible. Bathtub shaped contact there. One mega. $50 ohms. It's the same as the other one. Same kind of problems as the other one. I don't think, I don't think I'm going anywhere good with this. Wow, this is a sad situation. It's a really sad situation here. I could remove that control entirely from the unit. This thing seemed to work pretty good when I first started with it, and it went downhill. What would I gain from removing that? Well, you know what? I'm going to have to ponder this. We may have reached the end of the road here. Can't believe it. I'm depressed. I'm depressed. Okay. I don't know what to do. I gotta spend the day thinking about it. Oh, it's too bad. Hey, what's happening with the weather out there? And here's a look out the front of my house today. We're supposed to get a lot of snow today in the form of streamers coming down from Georgian Bay and Lake Huron. And Aurelia is positioned right for this kind of snow. So it could snow like a blizzard. It could stop and be almost sunny and then snow like a blizzard again in a matter of minutes. So at the moment, it's snowing like a blizzard out there. Okay, well, I'm going to go try to cheer up, and I'll catch you on the next video when I have something in mind to do to deal with that thing. Oh,